To Pavithra Laptop Care. Today I am going to discuss about 11th generation Dell laptop circuit schematic. Okay, as per one of our student request, I am going to discuss about this part by part. Today's section is 19 volt section. If 19 volt section comes into the circuit, what it will generate and what are the ICs will active, that I am going to discuss today. First, as usual, you have to go to charger section. Just type and search. Okay. Now this is the circuit. Okay, this is 19 volts V-in circuit. See, this 19 volts, from where it occurs, from where it comes, just you come down to previous page, you come to know. This is the battery section. And this is DC jack. This is the DC jack. So in this, pin number 6 and 5 is positive and pin number 2 and 1 is negative. Okay, this is complete loop. As I discussed previously, this is called a load. This motherboard is a load. Okay, here we are applying positive volts and negative volts. Here the flow of electrons from negative to positive, it flows. So this is called complete loop. In a complete loop, first voltage potential difference is 19 volts from DC jack. See, it will filter through these capacitors and finally the gives pure DC voltage in, what is that? After the PL1, it's a 19 volts underscore V in the name of 19 volts underscore V in. So first voltage generates in PL1. Okay, after that it comes to charging IC section. See, just you come down here, charging IC section. This is charging IC section. Here first MOSFET, it's a PQB11 drain, input of the drain, and next it comes to the charging IC pin number where DC in. See, this is the pin number. It comes through the PDB01 and goes to the input of charging IC. Pin number is 17. So here the charging IC will be active. It's a beginning stage, not fully. Okay, the input for the charging IC is provided by what is that, PDB01. That's called, it's a V-in. Okay, when you plug in the voltage in the first MOSFET and charging IC input, you will get. But charging IC won't be inactive completely. It gets only DC input. And also as a divider, the pin number 16, the AC in, AC dated, which we call, no, that one will generate, that one will active. Okay, see, in this case, when just we assume the, what is it, just a minute, again I will go to charger. See, if we assume this first MOSFET and second MOSFET is good and we get the CLR voltage, then what are the ICs will be active? Any guess? No? Okay. See, once CLR voltage is produced, it will be in the name of plus 19 VB. Okay. See, this is a common in first generation to 11th generation. What I saw, that I am going to explain you as per my knowledge. First, the CLR voltage is produced, then it actives all coil section of high-low MOSFETs. First, high MOSFETs. Okay, it goes to first high MOSFETs of every coil section. High-low section will be there, no? That section, high MOSFET will be active. The drain of the high MOSFET, we will get the CLR voltages. Anywhere you check the continuity through this CLR to that high MOSFET, so you will get the beep. This is the second condition after V-in circuit. First 19 volts V-in, that goes to charger and first MOSFET. If we consider the first and second MOSFET voltages are good, then we will get the 19 volts VB that will active the high-low MOSFET section, the high MOSFET drain. Okay, all section. And next, in this particular 11th generation board, individual ICs are used for 5 volts and 3 volts. That input it will active. 3 volts input and 5 volts input, like charging section. As well as RAM section also, it will get active. See, first one is 3 volts, 5 volts and RAM section. These 3 section ICs will be in active mode. Okay, so it's clear, right? So first V-in section will active first MOSFET and charging IC input. It goes to input. Second, when we get the CLR voltage, so all high-low MOSFETs in section, that section's high MOSFETs, and all input of 3 volts IC, 5 volts IC and RAM IC inputs we will get. Those ICs will get active. Once 3 volts section is active, it will produce 3 volts LDO. Okay, here see one secret I will tell you. Charging IC won't be in active condition because of this. See, because of this SDA and SCL. The SDA and SCL requires 3.3 volts, right? So from where we will get? It actives because of 19 volts, but it won't functions fully. Only we will get AC in and DC in. Okay, it may get we may get AC okay also, but what about charging and discharging path? So we require 3.3 volts, right? So this one, when we get the CLR voltage, then we get the 3.3 voltage LDO in 3 volts section. Okay, once we get the 3 volt section, 100% the IO will be active. Once IO will be active, then this ACK goes to IO and this charging section completely start working. The communication between battery and this charging IC will start. When the 3 volts and 5 volts IC will get active, when it will create LDO of 3 volts and 5 volts, then this complete charging section will be in active mode. Okay, so many students were telling this one first it will active. No, that's wrong. When 3 volts and 5 volts section gets active, then charging IC will be in active mode. Okay, so this is that's it in this section, because I wanted to explain you 19 volt section. Because of 19 volt section, what are the ICs are in active position. Okay, in next class I will explain because of IO what are the signals you will get. Okay, thank you. That's it. Thank you very much.